Okay, so this is problem number 2 on the Trig homework and the Algebra 2 homework. What we're going to do is we are going to follow these instructions for this set of data. First, we're going to find the equation of the best fit line using linear regression on your graphing calculator. Next, we're going to determine whether there's a negative or positive correlation in the data. Explain this correlation in a sentence, which is either a more or a more less relationship. The next thing will be to explain the meaning of the slope in the context of the problem. We'll be finding the slope when we find the equation of the line. We'll also be finding the y-intercept when we find the equation of the line, and we need to determine the meaning in context. We're also going to define or find the x-intercept. That's not in the equation directly. We'll have to calculate it, but when we do, we're going to explain the meaning of it in the context of the problem. So here's our data. We have different cities, and we have the distance from, let's say, a given city to these cities, and there's the airfare for each of the plane trips to this city, and we're going to type this into the calculator. So remember, you go to Stat, Edit, so you can push Stat 1. If you have data typed in, you just go up to the list, you clear the list, make sure you don't push delete. If you push delete, it will delete the list and you'll have to go get it back through kind of a complicated process. Okay, we're going to always use the first set of data as the x values. Alright, the first set of data is going to be x and the second set is going to be y. The x values will go in list 1. So we're going to just type them in, 576, 370, this takes a minute, 612, so you should be typing it in along with me, 1216, 409, 1502, 946. This is the most time-consuming part of the process. 737. Okay. Once you've got all of those typed in, you can go over and type the other values into the L2. These are the y values, and you have to make sure that you get the x and y values that are paired in the table. Make sure that they're also paired in the table in your calculator. If they're not, then you'll get an error message that will say dimension mismatch, or it just won't give you the right equation at the end. So as you're going, make sure you kind of look and make sure that you're on the right row and that you haven't accidentally skipped one. All right. And last one, 280. Okay. All right, now that we have all of our data typed in, we are going to do the calculation of the equation of the best fit line. So go to Stat, Calc, and we're going to choose number 4. That's linear regression. You can see that the ax plus b looks like a line. It's kind of like mx plus b. All right, so we're going to choose linear regression, and just push enter again, and there is the equation. Now, it says it right here, y equals ax plus b, and it gives you the a and the b. So the first thing that we're going to do on our paper is you're going to write down the equation. Now, it's a good idea to round it to like 2 significant figures, which means like the first 2 non-zero numbers, or you could round to 1 decimal place. This would be like 0.1 or 0.096. Because this is going to be money, airfare is in dollars and this is in miles, I'm going to round to the nearest hundredths place, so that's cents, but this would round to 10 cents. So I'm going to write it that way. Y is equal to 0.10, meaning 10 cents, x, plus, and then this one right here, this is money. So you could round to the nearest, cents, $200.64, but I think it's a better idea to just round it to 200. Okay, that way it's to the nearest 100, the nearest 10. It's not to the nearest $1, but it's close enough. Okay, there's our equation, and you can see that this is the slope and this is the y-intercept. Because it has a positive slope, that means it's a positive correlation. It's a more correlation. All right, so for part B, we're going to say it has positive correlation All right. And that means in a sentence, it's a more. In other words, the more distance, the more airfare. So you could say something like, the farther the distance, the more the airfare, the greater the airfare, the more expensive the ticket. I'm going to say the higher the airfare. Okay, great. Okay, so that's an explanation of the correlation. For part C, we need to explain the meaning of the slope. Now the slope, m, is 0.10, 0.10. We already talked about why that is. Now this means it's, if you don't have a fraction, you can write it as a fraction. All right, and since it's change in y over change in x, what's happening here is that it's the change in airfare price versus the change in miles. So we're talking about the airfare price, in dollars versus the distance in miles. Okay, so it's dollars per mile. So what this is saying is it's $0.10, which is 10 cents, per 1 mile. Okay, so the airfare, this is a rate, so the airfare increases 10 cents, so I'll put $10 cents, okay? 10 cents for each additional mile. All right, that's 10 cents change for every 1 mile change. Okay. The next is going to be D, explain the meaning of the y-intercept. I'm going to go to a new slide here so that you can see the new slide, the y-intercept. Before we do that, I want to remind you that this is the y-intercept, 200. Okay, so if this is part D, the y-intercept, according to the equation, is 200. Now what does that mean? Remember, a y-intercept is of the form 0, something, and the something is this number, this 200. So we have to remember that since this is x and this is y, and if you go back to this right here, distance is x and airfare is y, that means that it's 0 miles for the distance, okay, versus $200 for the airfare. All right, in other words, your plane ticket is costing this much. All right, so what is this really saying? This is saying 0 miles, $200 airfare. 0 miles of a plane trip, in other words, if you don't even get off the ground, if all you do is get onto the plane, they're going to charge you $200. And then they charge you more for every mile, about 10 cents for every mile, but they charge you $200 just to get on the plane before you even travel anything. Okay? The airfare is $200. There's lots of different ways you could say this, but the airfare is $200 even if you travel no distance. Now, is that realistic for the problem? No. And I mean, you wouldn't even want to pick numbers close to 0, like 5 or 10, because obviously you're not going to be flying in an airplane 5 or 10 miles. But that's what the equation says. So sometimes the equation makes sense, and sometimes the equation doesn't really make sense in the context of the problem. Okay, the last thing we're going to find is the x-intercept. Now, we can't directly see the x-intercept in the equation. All right, it's not listed here, only the slope and the y-intercept. So what you have to remember is that the x-intercept is of the form something comma 0. In other words, plugging in 0 for y and solving for x. So I'm going to take the equation. Here's my equation, y equals 0.10x plus 200, and I'm going to substitute 0 in place of the y and then solve for x. So 0 is equal to 0.10x plus 200. All right, we want to solve for x, so I'm going to subtract 200 over here to this side. So negative 200 would equal 0.10x. We then need to divide both sides by 0.10. Okay, so that's gone. That's a 0.10. All right, negative 200 divided by 0.10 is just going to leave, it's going to be 2,000, negative 2,000. All right. Equals x. So that's saying the x-intercept is negative 2,000. Okay, and that's miles. So what is that saying? Negative 2,000 miles is $0. So does this make sense in the context of the problem? Does it make sense that if you wanted to pay nothing for your airfare, you'd have to go negative 2,000 miles? You can't travel negative 2,000 miles, not in the context of this problem. So we can write down that it would be negative 2,000 miles to have your airfare at 0.